I'm well. Today is the seventh day in my marathon where I am solving leetcode problems in PHP and making videos about it. And you, for some reason, are watching it. If you are paying attention, that you might notice that this problem is already appearing as solved for me. That's because this is my second attempt in recording this video, and actually first attempt was just fine. I solved the problem, as you can see, but I forgot to turn my microphone on. So I'm doing that not for the first time, so indulge me if I may be not clear enough, or maybe I would be more clear than usual. So today the problem is from medium category. It's called largest combination with bitwise and greater than 0, and obviously the topic is bitwise operation. What are bitwise and? Bitwise and is basically multiplying binary numbers. Like this, we have example of 1 which is represented is 001, 5 which is represented as 101, and 3 which is represented as 011. And if we calculate bitwise AND for them, we need to multiply 1 and 1 and 1 in the last position, and we record that as 1 here. Then we multiply 0, 0, and 1 in the last but 1 position, and sorry, and we get 0. Yeah. And here we multiply 0, 1, and 0, and we get here 0. So this is what bitwise multiplication, it's called also bitwise AND, looks like. In this particular problem, we are given the array of candidates, and we need to return the size of the largest combination. So basically, the number of elements in the biggest subset of candidates that produce greater than 0 bitwise AND. We have two examples here. One is stupid. We are given two equal numbers, obviously, and between them is going to be the same number. So we just return the count of the elements in this array, which is 2. Here is more complicated example. We have 7 different numbers, and 4 of them generate bitwise AND equal to 16. So we need to return 4. There are no 5 elements that would do the same, that would produce non-zero bitwise AND. So actually, when the bitwise AND for any number of numbers is not equal to 0, it's not equal to 0 when it has 1 in when all of them has at least one same set bit. So if they have at least one element that has 0 in that position, that it ruins everything for that subset, right? For or combination, how it's called here. So we need to find the position that has the most set numbers in this array of candidates. So in order to do that, let's create a function that would return all the bits in the number, get bits. So basically, this is converting the number to binary. We are doing this by shifting bits to the right one by one. The last bit can be recorded like this, and shifting to the right looks like this. Here we return bits. Let's quickly test this function. Let's output the number. Let's output its bits. And let's also add the line break here. Let's see what we are going to get. Okay, it's obviously not working as we expected because I forgot to convert the array of bits into string for debugging purposes here. Let's see. Okay, 16 we got, yeah, so we are getting reversed binary representation. So here we get number of ones, here we get number of twos, here we get number of fours, number of eights, and number of 16s, and so on, so on, so on, so on. That's actually very good because we can stop worrying about mismatching the positions. We are returning bits from the smallest one to the biggest one. So, and now we should actually count number of elements that have specific bits set on, like this. So we just iterate through the bits. So pos is index and bit is 0 or 1. So we can simply increase counter by bit. If it's 0, it means that nothing changes. If it's not 0, let's look at the counter here. Okay, what does it mean? It means that among these 7 numbers, 2 of them has last bit set to 1. Last bit is actually a number of 1, so it means that there are 2 even numbers. No, sorry, 2 odd numbers. It's 71 and 17. And like, yeah. So basically, there are 3 numbers that have last but 1 bit set. It is, I would say, 61, 14, and probably something else, which I cannot quickly tell you. Yeah, sorry, second time recording the same video is exhausting. Let's try to return maximum element within these counters and see if it's going to do the trick. Yeah, it does. Let's submit. Okay, I know that it will work because I already tried it. Thanks for watching this. I'm sure that you disagree with my approach. You object to my algorithm. Feel free to post the comment and tear me into pieces, or tear me a new one, as they say in the US. Also, feel free to subscribe to this channel and also follow us on GitHub. Links are in the description of this video. Cheers.